All right, let's do some examples this time using the natural logarithm base e. Remember what that means is that if we're going to evaluate a natural logarithm, we're going to be using the notation ln of whatever number follows. So we might be interested in, say, finding the natural logarithm of a number like 293. Well, the natural logarithm of 293, I don't know that off the top of my head. I better go to my calculator. So 293, I'm going to take 293, and I expanded out my Windows calculator for this one. You see the button ln right here. That's the one we're going to use. So we're going to take the natural log of that. We're going to get 5.6802. 5.6802. So that's what we're going to write in here. 5.6802. Remember, this is always an approximation, but I carry it out a number of digits. Well, what should happen with the natural logarithm of 0.002086? Well, in this case, one thing that I might note right away here, we noticed this with our last set of examples too, was that when we had a logarithm of a very small number, we got a negative as a result, but when we took a logarithm of a positive number, we got a positive result. So let's see what's going to happen right here. This should be a negative number, right? 0.002086. When we take its natural logarithm, let's find out what's going to happen. So I'm going to come over here to my calculator. I'm going to enter in 0.002086. I'm going to take my natural logarithm of that number. And sure enough, I get a negative 6.1725. And that's what I'm going to go ahead and enter as my answer in this case. So I take that to be my solution. And I just would want to point out, in this case, we're going to get negative or positive numbers out from our logarithm depending on what we put in. Negative 6.1725 here in this case. And the reason that we're going to note that is this. If I were to take my natural logarithm of 1, just go ahead and put that in your calculator right now. What do you get? Well, you're right. We get 0. Okay, so if the number that we put in is less than 1, we're going to get a negative number. If the number that we put in is greater than 1, we're going to get a positive number. So that makes a nice little trick that you can use to sort of check yourself, am I getting the right value out? Okay, now find the natural antilogarithm. Well, that was the one where we're taking e to the number. So what we're really asking you to do is find e to the 5.420, right? And find e to the negative 2.94218. So that's what we're going to do. We'll open up our calculator and we'll take e to the 5.420, and we'll take e to the negative 2.94218. All right, so let's check that out right here. I'm going to open up my calculator. This time, I've got 5.420, and I wanted to find e to that number. So here's my e to the x key. Right in your calculator, it might actually be shift over the ln, right? In my case, in the Windows calculator, not so much. So I'm just going to hit e to the x. Oops, that's not what I wanted. What happened? 5 point. I missed the point, right? 420. Now let's hit e to the x. There we go. We get 225.879. So let me go ahead and bring myself back to the sheet right here. And sure enough, my answer, I'm going to write as approximately 225.879. Okay. E to the negative 2.8, we should get a decimal this time, right? Just kind of like we had a nice decimal right here. This natural logarithm gave me a big negative. Well, when I take the anti-logarithm, that negative should give me a decimal, less than 1. So let's try it out just to ensure that's the case. So I'm going to go back to my calculator. Clear this out. I'm going to put in 2.94218. 218. I want to take the negative of that value, and I'm going to take my natural antilogarithm, that is e to that number. Hey, yeah, and sure enough, right, just like we predicted, we're going to get a decimal, 0.0528. I'm going to carry it out at 4 decimal places right here. So let's go ahead and enter that in. We've got 0.0528 as my answer here. Okay, pretty good. Just going through and exercising our ability to get logarithms and antilogarithms. More examples to come.